Okay, I am back, Abby, for the last little bit here that hopefully I tried to fill it in before I was actually doing the video so that it seems less confusing, because my goodness gracious, as I was trying to fill that out for you, it was awful. I felt so bad that I was making it seem so complicated. So we finished talking about our example. And now I want to talk about the problem that your teacher actually gave you. One of the problems, because the other problem your teacher gave you, you're going to solve. But let's talk about this first one here. So find the length of the dark arc. Now, the only reason that they said about the dark arc is kind of going back like what we were talking about when we were struggling with this problem. And I was saying how, I really wasn't sure on this arc length of km. Was she looking for the minor arc or was she looking for the major arc? It was left a little bit, kind of open to interpretation there because the actual arc they're looking for wasn't marked. But that's all this means in this problem. They clearly defined what arc they're looking for. And challenge question for you. Is this a major arc or a minor arc? Minor arc, yay, fun. Okay, anyways. So, like we said, step one, we're going to write out our formula. You know what? And I'm going to turn on my phone because I want you to watch me too. Because I know you're going to have this, but I'm going to send you a video, like an actual video of me. Because I want to be able to show you this calculator thing that I was talking about. So that way you can see exactly what I'm doing when I do it. Okay, video. So I'm going to put this over here. And then I've got my PowerPoint going that you're going to be watching. Okay, so, and let me flip past that crazy set of notes that I made because it looks like crazy business. So our circle says we have our circle and it has a radius of 17 feet. And then the central angle is 120 degrees. Okay, so that's what I have written down on my paper, if you can see it. So even though you're doing this virtually, and even I have this up virtually, I would rewrite the circle like I did in my notes when I was actually solving these, to check myself for you. I wrote them down because it's helpful to write them down so that you can mark exactly what it is that you want or that you're needing to find. It helps you make sure that you're not going to make a mistake, all those kinds of fun things. All right, so we have a radius of 17 feet and our central angle is 120 degrees. So step one says to write out our formula right here. Step one, write out your formula. So I'm going to write out my formula to find the length of an arc in degrees. It is 2 pi r. And then I have in parentheses, central angle over 360. And then I'm going to close my parentheses. Okay, so that's what I have written right there. Step two, fill in what you know step by step. I know it's obnoxious, but it'll stop you from making a mistake. So I am going to go across my formula and I'm going to fill in what I know, but I'm only going to do them one at a time. Okay, I'm not going to try and jump into it and try and fill in every single possible thing, because as you get further into calculus, you're going to have things that you have to fill in, say 10 different items. You don't want to miss one. So you do them step by step. So I'm going to look at my formula. 2 pi r. Do I have r? I do. I have r right here, 17 feet. So 2 pi 17, and that's what I have right here on our screen, and I highlighted it so you'll see it. And then in my parentheses, I still wrote out the basic part of the formula, that central angle over 360. I mean, I know I can see it. I can see that 120 degrees. So I know it's going to go there. But I'm going to write out the rest of my formula anyway, and then move on again. Step 3, finish filling in what you know. So I'm going to write it again. I'm going to bring down this. Let me get my pencil from the computer. I'm going to bring this 2 pi 17 down here. Okay. 2 pi 17. Okay. And now I'm going to fill in the next item that has been provided for me, which is my central angle right here, this 120 degrees. So I'm going to have 120 over 360, and I will close my parentheses. So let me change that here. 120 degrees. Really? This just is something else, isn't it? All right, so 120 degrees over 360 degrees. Okay. So now, and that's also what I wrote on my paper. Now I'm going to start solving. Now, if you remember when we were talking about it up here, we said that we solved it piece by piece. We solved this first piece here first, this 2 times pi times 10. In this problem that we're working on right now, we're going to solve this portion first, this 2 times pi times 17. Okay, so let me copy, start solving. There you go, 2 times pi times 17. And I'm going to write it on my paper as well. 2 times pi times 17. Actually, I don't know why I did that. Look, I went through all this work. Okay, I'm going to pull up my calculator so that I can find it. I'm actually going to use this calculator this time so that I can show you what I was talking about, because my video, for some reason, does not want to work. I don't know why. The other video that I did. Let's see. Let me pause this video that's actually on my phone. I'm going to pause it because I don't want it to be too long and I can't upload it. So 1 second. You're still going to have your recording for your YouTube, and I'm back on my regular video. So with your TI-84, I'm going to turn it on and I want you to see something here. Okay. On your TI-84, I don't think this is going to let me flip my camera around, is it? No. On your TI-84, like I said, you have your modes, your degrees and radians. So if you take your calculator and click mode, it is the button right here next to that second button. Click mode and a whole bunch of craziness is going to pop up. Okay, so within that craziness, if you look on the third line down, do you see where it says radian and degree? I'm going to go down there with my arrows. Radian and degree. Radian and degree. If you are solving, oh, what'd I click? Okay, I'm good. If you're solving your problem to find the length of your arc in degrees, you need to make sure your calculator is set in degrees if you so happen to be using a TI-84 calculator. Because if you plug pi in there, like the actual pi symbol, which is right here on your calculator, see the arrow right here? If you click the second button, the blue second button, second, and then you click that arrow, see where it has the blue pi button right above it, and you click it, it will actually put pi in your calculator in the actual symbol, so that you can see that right there. But if your calculator is set in radians and you put that pi symbol in there and don't put 3.14, it's going to do something totally different. You're going to end up with a different answer. So that's definitely something you want to look out for. But right now, we don't even need a TI-84 calculator to solve this problem. We can use the basic calculator that we have been using on the computer. So I'm going to turn off my video on my camera. So bye-bye, that's going to go, and I will send that along to you so you can see that on the calculator. And then finish the rest out on our video. So, let me get my oh, there's my calculator. It's still up. Look. All right, so we have 2 times pi times 17. Let's find out what that is. 2 times 3.14 times 17 equals 106.76. 106.76. Now, I wrote that on my paper, Abby. By the way, I know my video is not on, but 106.76. I just want to let you know that I put it on my paper. And then the next thing that I'm going to do is I am going to write out this 120 degrees divided by 360 degrees. I'm going to write it again. Okay, I'm just going to leave it like that. Does that bother you? Or I'm not sure. I don't want to make it confusing, but I know that it's facing, you know, the different way than this is. Instead of straight up and down, it's going this way. But this is divided by there we go. Okay. Just to make sure. I know you know that I know at this age you probably know that slash means divided by, but I just want to make this, you know, as clear as possible. So the main thing that I'm showing you here, though, is that all I solved so far was just this 2 times pi times 17. And then this part right here, this 120 degrees divided by 360 degrees, I carried that down, okay? Because I am going to write it again so that I don't miss anything. I don't want to miss anything. So I carried this down, okay? So now I'm going to solve right here what's in this parentheses right here. This 120 divided by 360. Let's see what that is. 0.333333. Fun. So it is 0.33333333, whichever. So let's round to the nearest hundredth, which is obviously going to be 0.33, because it just is an infinite there. It's never going to end. 0.33. So let's get that written down. Here we go. I wrote it on my paper, and now I'm going to put it on my slideshow for you to see. Text box. Okay, I know that we're still on the same slide here, and I'm kind of moving, you know, over in this direction, but step 4, I have 106.76, and then we just found out what 120 degrees divided by 360 degrees was, and that was 0.33. We're just gonna let it end. Equals. Now we can plug it into our calculator and find out what it equals. Okay, so let's see. Now I'm going to leave this. No, you know what? I'm not. I'm just going to redo it. You could just leave that 0.33 there and then times it by the 106.76, but let's just clear it out and again start from the beginning so we don't make a mistake. 106.76 times 0.33 equals 35.2308. Now I'm going to put that whole number there. Whoa, I forgot what it was though. Let me write it in my paper so I can type it into the computer. 35.2308. Okay, so we have 35.2308. Now let me look at my pictures just to make sure what your teacher said, what she wants you to round to, because I can't remember. Abby, where you at? There you are. Okay, Miss Abby, you need to be rounding to the nearest hundredth. All right, so the 2 decimals place, she says. All right, so we're going to be rounding to the nearest hundredth. So right now we are definitely not at nearest hundredth because we have 10th place, 100th place, and then it just keeps on going. So we are going to round. So if we need to stop right here at the 100th place, let me make sure. Why do I feel like I'm weird? Like I'm not telling you what the right 100th place is. Look, I can tell you how to find an arc, but let me just make sure. What is the 100th place? Tenths, hundredths. Okay, I am right. Okay, I was like, what? Okay, I just wanted to make sure. So it goes tenths, hundredths, thousandths, and then 10 thousandths. Okay, that's where I was confused. I was like, what comes after that thousandths there? But anyways, so we're going to round to the nearest hundredth. Stay right there, Sam. Sorry, Abby. I'm about to be interrupted. Just wait, Sam. You can stand and watch if you want to learn some calculus. Or, yep, that's what I thought. She left. So we're going to keep this 2 because that's 10th place. This 3 is where we need to stop. 0. So we already know how to round. Okay, if it is 5 or under, then that number stays the same. If it is 5 or over, our number is going to go up. So the next number is 0. So that means our 3 will stay the same. So we'll get rid of those last 2. And it was in feet. So we need to make sure that we add that unit there. Make that bigger for you. So here is our answer for our arc length of the dark arc in this example. Pink! That's what we're going to highlight it in. Shut up, Shannon. Hold on 1 second. Sam, let her go. Okay, I think maybe my pizza's here, Abby. But that is our answer. 35.23 feet. That is the length of our dark arc for this circle example. And now what I want you to do is I want to see if you can find the length of the dark arc for your next problem on your own. I think you can do it. I know you can do it. I don't think you can do it. I know you can do it. And I will also attach and send you those separate videos of me when I was showing you the stuff in the calculator, because I know on this video that's recording my computer screen, you can't see it. So I'm going to stop this and then I will get it to you in just a little bit. Bye-bye.